Alright, so chapter 6. General percentages. Right, so this I love to start the class this way because it sort of reminds you. You guys know that that statement is true, right?
Mm-hmm.
What am I going to ask you?
Change it to a decimal or a fraction?
No, I'm younger than that, folks. I'm 4 or 5. What do 4 and 5 years old say? To everything.
Why?
Why? You have to say it the right tone. Okay, so my question to you folks is, why is this true? If you had to explain this to someone who doesn't know anything about decimals or fractions or percentages yet, why would this be true?
Because we would put 50 over 100, and then if you reduce the fraction, it would be 1/2.
I absolutely agree that that's correct, but where did you get the over 100 from? I don't see that anywhere.
There's nothing
100 is your whole.
100%.
100 is a whole?
Yes, 100 is a whole.
So every time I draw a hole, I'm really writing the number 100?
It's
no,
it's
the whole unit.
right.
Okay.
It's like 100% of the pie was 50% of the pie.
Why is 100% of the pie the whole pie?
Because you don't have to cut it up proportionate, so 100% is all of it.
Why?
Oh, Lord.
Somebody
Well,
said it.
isn't
So,
it?
okay, so here's another question. Why is that true?
Because it
Isn't
can't
it
be
if you
higher.
divide it, like 1 divided by 2 is 0.50, whatever. And then
I don't have 0.50 up there, though.
Yeah, but you times it by 100.
Why? I don't see times by 100 anywhere up there.
Well, it just is.
An acceptable answer for a parent to give a child, but a really bad one, right? You can say that to your kids, you say, because I said so, but it's really the wrong way of doing it, right? The child learns nothing if you do that. You really want to be able to explain it to them.
Because it just is.
Nope, that doesn't. Then I am not going to accept that because I'm not a 4-year-old. I'm a 40-year-old or 50-year-old, 4-year-old. So, why?
Because someone older than you started it.
But
And he proved it.
what's the proof, folks? How would you explain it so that they really get it, right? This is the key.
Well, isn't that why we're in the class, so that you can teach us why?
Well, no, I completely agree, but you knew this was true already.
Yeah.
So why can't you just explain why?
Well, now I can't explain why I can't explain it.
I mean, you can use the fact that you know about percentages and fractions already to explain percentages, but you can't use something to explain something, right? You can't say, why is money money, by saying, well, because money is money, right? And you have to give an explanation as to why. A reasonable explanation that's outside of the scope of what you're talking about, okay? It's basically like trying to teach people obvious things like 1 + 1 is 2, right? I mean, how do you show somebody that 1 + 1 is 2? You have to make sure that they can count, right? So
Would it work like if you drew basically, okay, here's a pie, and I draw a line, this pie represents 100%, you
Okay.
draw a line.
and unfortunately, I would ask you, why does a pie equal 100%?
Because the pie is one whole unit.
Why is one whole unit of 100% though?
Because it's complete.
I feel like the
Because
answer's in the books.
I don't even know if the book talks about this. This is more basic than that. Because this is, again, you guys know that this is true, right? I don't really need to explain to you this. But what I want you to be able to do is that when someone else asks why, who doesn't know what percentages are to begin with, you can do it. And the question then is that what mathematicians are doing here is that we're simplifying this problem, okay? What does that symbol mean? Without any number in front of it, just by itself, mathematically.
Percent
Per
equals part.
100. That's what it says in the book.
It says?
Percent means per 100.
Per 100, right? This means per 100. What does the word per mean mathematically?
Indicates
For every
hundredths.
Exactly. Or so if it's worth every 100th, what are you really doing with this per 100? What are you going?
Each.
Each. Yeah.
One.
What mathematical operation am I going to do?
Oh, I haven't gotten it for.
Divide.
Divide.
Yes.
Okay.
This is, and that's why, folks, because the percent sign is a mathematician who's been lazy and doesn't want to write divided by 100. That's it. Okay? That's what percentages mean. They mean per 100 or out of 100, right? So it has a straight definition. It's one of those things that's so obvious you forget that it's true. Okay? Again, you guys all know why and what these things are. It's just that now when if anybody ever asks you, you'll be able to give them a really solid mathematical definition. And the definition is this symbol translates to out of 100. And that means divided by 100.
So does that mean when somebody says, well, I'm going to give it a 110%, that's not a real thing?
Yeah, essentially.
Okay.
Yeah, because there's never anything more than 100. You can't have more than 100% of something.
You can.
You can.
That's what you get for listening to me.
How much has the cost of college increased in the last 5 years?
Yeah.
Yeah, more than 100%, right? More like 1,000%, right? So you can have more than 100%, right? It's just that that's when you're comparing things that are not necessarily of the whole, right?
It's like a
This makes sense though. In book it says percents are results of expressing numbers as part of 100. So basically
Yep.
it could be like 100 parts of 100.
Yeah.
Or
50 parts of 100 is one
That's
half,
where I got
right?
my answer from.
Yeah.
Okay, and that's essentially that's what it means. But again, remember that it's the percent sign, right? A percent sign is just a mathematician's way of being lazy. Okay? Which is of course why I don't really like percentages, because I would really rather just do it the way it should be done instead of having to use these percentages. But unfortunately, folks, does the world work that way? No, everybody hates mathematicians, so they want to use the percent sign. And again, the reason why you want to use the percent sign is because technically, we don't like seeing fractions, and we also do not like seeing decimals with no numbers out in front of them. Okay? We just don't, for whatever reason. Okay? So when we see 50%, we're really happy. But if we see 1/2 written as a fraction, we're like, oh, I don't like fractions, right? I mean, but now you know, in theory, that you don't necessarily have to worry about it, okay? So, one of the things that then you should be able to do is with any percent, you should be able to always give me its fraction and decimal representation, okay? And this will actually be the first question on the next test, okay? This is what it's going to look like. I'm going to give you a table. Table's going to have 3 columns. It's going to have percents, it's going to have decimal, and then it's going to have fraction. And what I'm going to do is I'm going to fill one of those boxes, and your job is to be able to fill the other 2. All right? So, start relatively straightforward. 25%. How do you write that as a decimal?
0.25.
0.25. And how did you know that?
That's half of one. Is it 25% of one?
25% of one, right? 25% is a quarter of something. And how do you write a quarter? Well, it's 25 cents. Or, the way you might want to think about it, right, is that, remember, what does the percent sign mean again? Divide by 100. If you take 25 and divide by 100, what are you really doing? Moving the decimal 2 to the left. That's how you convert from percent to decimal. Move the decimal 2 to the left. Now, how do you write this decimal as a fraction?
25 over 100.
25 over 100. Excellent.
You can reduce that.
Yeah.
But you would never leave that fraction like that, right? You would reduce it to
1/4. Because
One.
25 goes into 25 once and 25 goes into 100 4 times, like she said.
And, as you said, this is a quarter. How do you write a quarter? Well, you write it like a quarter. Right? Okay, so not too bad, right? Now it gets fun. So, be careful, right? So what if I give you something like 4%?
0.04.
Okay, good. Note, 0.04, right? Please note that the decimal point must always move twice and only twice. Thou shalt not count to 3. 3 is right out, right? 1, 2. Okay? If you get to 5, then we really have a problem.
And
Exactly, because technically what is this number read properly?
Well, 4
4 100ths. And how do you write 4 100ths? Over. This is why I like to sort of remind you guys how to read numbers. Because when you read them, you actually get the fraction, right?
I'm scaring myself. But okay, go ahead.
But you're not going to stop there, right?
Because, yeah, I reduce.
Yeah. So you will always reduce. And I will also write at the top of this test, just in case you don't remember, please reduce all fractions all the time. Because, of course, remember, that was the first sentence on the last test, right? And you guys made sure you did that all the time, right?
For sure.
Especially in those first 2 questions.
Hope so.
Okay. I literally have not started grading you guys this test yet. So I don't know how you did. I really don't. I was waiting for all of my online class people to turn in the test, and someone took the test yesterday, so I just didn't even bother looking at yours. And I've had enough car fun in the last 3 days that, yeah, enough said. Okay, so let's see.
7, 0. And set me over 100.
Oh my gosh, I'm so slow.
And note, you don't have to write the 0 if you don't want to, right? It can be just 0.7. If you want to write the 0 in there, that's perfectly okay. It's not wrong. It's just weird.
7/10.
Yeah. And this is 7/10, so write it as 7/10. Not bad? Okay, good. So now let's try another one. Let's suppose I am a football player, and I always give 110%! Because that's what you do in football, right? That's what they always say. So, what is 110% written as a decimal?
1.1.
Okay, good. Please move the decimal 2 places and only 2 places. Thou shalt not count to 3, right? It's right here. You go 1, 2. Stop. If there's a number to the left, don't freak out. Just let it be there, right? And how do you read that number correctly?
1 and 1/10.
1 and 1/10. It's in the 10th place. And how do you write 1 and 1/10?
1 and 1/10.
And if you want to, you are more than welcome to write it as an improper fraction. I'm happy with either one, okay? So when the fraction piece comes along, if you have an improper fraction or a mixed fraction, don't worry about it, okay? Alright, so. So what if I give you, 0.01%. And why would I give you this number, by the way?
I'm just making a life harder.
Oh no, there's a very real reason why you need to know what this percentage is. This is probably the interest rate that you're earning on your money in your checking or savings account.
If we were to have money in our checking or savings account.
Even if you have $4 in there, you're still earning 0.01% compounded continuously interest. You really are. Granted, it very rarely amounts to much if you don't have much in there, but that's what the interest rate is. So you need to be able to deal with that percentage. How would I write that as a decimal?
0.0001.
All right, good. 0001, right? You keep moving the decimal point to the left when you're converting, and it's always 2, right? Fill in any blank hops with zeros. Make sure you have the right number of zeros. All right?
Then would it be 1 over 1,000? Or 10,000?
You tell me.
Because I think the decimal stands for 0, so I want to say 1 over 10,000.
Decimal stands
Tenths,
for and.
hundredths, thousandths, 10,000ths, 1/10,000th. And again, please note, folks, the same rule applies that we were learning in the last spot. How many decimal places do I have?
4.
4 decimals,
4 zeros.
4 zeros. I would really like you to be able to tell me that that means 1/10,000th, though. I really want you to do that. But if you just remember the Same number of decimals, same number of zeros. That always works. All right, so one more just to be safe. Safety first here, even though I don't technically practice it. And I was literally running down the stairs 3 at a time, so I honestly blame myself, but whatever. So I tell you that the cost of college has increased by 1,000% over the last 5 years. How do you write 1,000% as a decimal? You don't do anything different. Same thing you've been always doing, right? What are you doing in all these other ones?
Is it
10.
10?
It's 10.
Yeah, it's 10. It looks weird because it's not a decimal, but that's because your percentage is so big that there are no decimals, right? Here's where the decimal is. 1, 2.
So, like, say that was on like a text, do we have to put like 1 0 decimal 0?
No, 10 is
Just
perfectly
write
good.
10.
10 is perfectly good. I have no problem with 10. Now, how do you write 10 as a fraction, folks?
10 over 1.
10 over 1. That's the improper format. How do you write it as a mixed fraction?
10.
10. Good cheeky answer when you can just write the same number down twice in a row and it's correct. I like those sorts of things. Hint, hint. All right? Not too bad, right? Going from percentage to everything else. Got to be able to go both ways, though, folks. So what would you say if my decimal was 0.06?
6%.
Why?
Move decimal places to the right.
2 places to the right. Note, when you're taking a percent off, you move your decimal to the left. When you're putting a percent on, you move it to the right. Okay? So to the right when you're going from one side to the other. And what is that number again? Read correctly?
6 over 10. 6 over 100.
6 over 100.
Turns into 3 over 50.
3 over 50. Not bad? Alright. Alright, well what happens if I give you 0.6? Okay, good. Alright? Note the difference, right? You still move the decimal point twice. That second hop just gives you a 0 so that you're at 60%. 6/10.
3/5.
Why is it 6/10 instead of 6 over 100?
Right.
What spot is this?
60 over 100.
This is the 10th spot.
Yep.
So it's
Mhm.
6/10.
Yeah.
Oh.
Whereas this one was in the 100th spot, so it was 600.
Oh, okay.
Alright.
I
Remember.
gotcha.
The number of decimal places equals the number of zeros on the bottom.
Yep. And how many decimal places do we have?
1.
1.
Oh, I got
Hence,
2.
1, 0.
Okay.
Yep.
I gotcha.
All right. So what if I had 2.2? 220%. Good.
And 2 and 2/10 or 2 and 2/5. 1/5, I mean.
2 and 1/5. Yes. And again, you can also write it as 22/10 equals 11/5, whatever, if you want to go improper. Either way. All right, not bad. All right, so let's try 0.001. Hmm? 0.1%. Make sure, folks, that if you are going to write 0.1%, that I can see the decimal point. Okay? be explicit. Make sure the decimal point is big enough that I can see, right? Doing this,
That's 1%.
yeah, that's 1%. Even though, well, but see that little circle right there in the 1? I just wrote that percent. No, that you screwed it up, okay? So please be explicit when you are writing your decimal percentages so that I can see where the decimal point is, okay? Just denote. And then what is that as a fraction?
1 over 10?
No, 1 over
1 over
100.
100, because there's
1
over
over
1,000.
1,000. There's 3 decimal places.
3 decimal places, 3 zeros, 3 zeros is 1,000. Okay? So far so good? We'll get there. This is why we go over it, right? Because so that you don't screw this up on the test.
I
Okay?
would think we wouldn't.
Alright, so, and then last but not least, let's say 20. Again, remember you're moving the decimal to the right. It's right here. 2 hops. Just adds you 2 zeros. How do you write 20 as a fraction? Yeah. You can write it as an improper fraction, or you can be cheeky and just write 20. Alright, so those are working with the decimal column. Now let's work with the fraction column. Fractions, yay. So let's suppose I gave you, suppose I gave you 13/80ths. Please remember, folks, that for the next test, you get to use your calculator 100% of the time. What does 100% mean again?
All of it.
The whole pie? Okay, so how would you do this problem?
13 divided by 80.
Exactly, you get at your calculator, you just punch in 13 divided by 80. Please take the shortcut, it's very okay. Alright? So what do you get when you do 13 divided by 80?
1.165.
Note that that gives you the decimal 16.25%. So note, if I give you a fraction, folks, or if you're asked to convert a fraction into a percentage, my advice is always go through the decimal. Convert the fraction into a decimal, and then remember that you know how to convert that decimal into a percent. Okay? Just don't forget that step, right? What I often get people telling me is that 13/80ths is the same as 0.16525%, and that's just blatantly wrong. Okay? So be careful. All right? All right. So let's see. Let's go with. Yeah, we can jump right there. I think you guys are ready. Note, the other thing that it will say on the top of this page of the test is do not round anything in this problem. Okay? So how do you write it so that you don't round it?
0.3 to the line over the
Okay, good. Right? So just like we talked about back in chapter 2, when we talked about fractions, if you are asked to not round, then don't round this. Don't tell me it's 0.333333333333333 and then stop. Because you know that 3 goes on forever, right? Just because your calculator stops doesn't mean that the calculator's right. Please remember that your calculator does lie. Or it rounds. So if you just copy the numbers from a calculator, you may be rounding, and if I say don't, well, then you're wrong. Okay? So be aware. Now, how do you convert that decimal into a percent?
Wouldn't it be
33%?
33.33.
Yeah. So no, remember that this 3 repeats forever. So when you move the decimal over 2, do all the other 3's disappear?
No.
Nope, they're still all there, right? So
How many of the 3's do you want us to show? Because I initially wrote 33.33 with the line over the...
as long as you have a line over any part of the 3's, I'm happy.
Okay.
Technically, it's a lot cleaner if you just write 1, but if you wrote 2, that's fine. Now, folks, how would you rewrite that percentage so it doesn't have that weird repeating decimal?
33%.
33 and a third percent.
33 and a third percent. Where does the third come from?
It's the 0.3 with the line over.
Yeah, because remember what you guys just told me. You guys just told me that 1/3 is the same as that 0.3 repeating forever thing, right? So if you want to get rid of that 0.3 repeating forever thing, just use the fact that it's equal to 1/3. That percentage, 33 and a third percent, very common percentage to see floating around, right? Now, what most people do is they say, oh, but this is basically the same as 33%, and my answer to them is always, no. It's not. 1/3%. Everybody says, well, but that's so small, who cares? And I'm like, 1/3% of
$1 million.
of $20 trillion, which is our U.S. debt, folks. That's billions of dollars. Okay, it makes a difference, right? So if our interest rate for our government debt is 33% instead of 33 and a third percent, that would be way better because that third percent makes a difference. Okay, so please be careful with it. All right, so now let's try another one, similar vein, but bear with me. All right, so let's do 5/6.
0.833 with the line over it.
So what am I going to write?
0.833 or 83 with the line over the 3.
The line over the 3. Note it's just the 3, right? Not the 8 and the 3, just the 3.
It's 83.3% with the line over the 3.
Okay, good. So 83.3 with a line over it percent. And how would you write it without that stupid repeating 0.3 thinger?
83
1/3 again.
Yeah, it's 83 and 1/3 again. Right, good. Because remember that the 0.3 repeating is 1/3. Not 5/6, but 1/3. Okay? Not bad? Those are fun. I mean, those are just really fun. Because it, again, reminds you about how repeating decimals and fractions are basically the same thing. Alright? Alright, so let's try the other side of the coin. Let's see if you guys can do it. Alright? Let's suppose that I do 1/6. First off, explain to me what your calculator did to you.
It repeated the 6 a bunch of times and then put a 7 at the
Why did it put a 7 at the end?
Because they round.
Remember, your calculator is always lying to you. It always rounds the last digit. So it should be 6s forever. But because the 6 after the 6 makes the 6 round up, it turns it into a 7. That's the calculator lying to you, or doing as good as it can when it comes to showing you the number, right? So how am I going to write this number?
1/6 with a carry over the 6.
Yeah, with just a line over the 6. And what does that turn into a percent-wise?
16.6 with carry over the 6.
Exactly.
16.16.
And now here's where you got to be a little bit cautious. Remember, it's not 1/6 because 1/6 has a 1 in front of the 6, right? There's no 1 in front of this 6, right? So you can't tell me that it's 1/6 because that needs a 1. This has no 1. It's just all 6s.
6/10.
You're on the right track. It's not quite 6/10 though. That would be if there was no line over it, right?
3/5.
You're getting closer.
2/3.
What?
2/3.
Why 2/3?
Because 1/3 times 2 is
Yes, yes.
Yeah.
1/3 times 2 is 2/3.
Right.
And if you take a bunch of repeating 3s and multiply all of those 3s by 2, what do they all become? 6s. Ah. And get out your calculator, folks, and put in 2 divided by 3. What does it give you?
0.666 and 17.
Oh, this is just the start of the math rabbit hole, folks. Okay? I'm not expecting you to be able to do these sorts of things. I am happy with either of these answers. If you leave the bar over the decimal point, you are perfectly fine. You do not need to convert it into the appropriate fraction. It's just really cool if you can, okay? Because this number looks way, way, way the hell better than a number with a frickin' line over the percent decimal, right? I mean, that just looks weird. Most people are going to look at this number and say, why did you underline the word above 16.6%, right? That's what they'll say. Because they don't understand that this means a repeating decimal, even though they really should, okay? So it is good for you to be able to do this, but realize I'm happy with either, okay? All right, so let's see. And note, folks, I won't be mean with you when it comes to these numbers. I won't give you something like 3/7 where the repeating decimal part is really, really nasty. I won't go that far down the rabbit hole, okay? But let's see. I might give you 10 and 1/100. How do you write that as a decimal?
10.01.
Uh-huh.
Why is it 01?
Because it's just 1 and
Because if you
10
just-
and 10 and 100.
How many zeros do you have?
I keep doing the 10 instead of 100.
Yeah, if you've got 2 zeros, you need to have 2 decimal places. And since there's only one number on top, you have to have a 0 leading.
1,000%.
Exactly. Again, converting to percent, multiply by 100, move that decimal to the right. 1,001%. All right? These are fun. These are just, they force you to think mathematically, get you more numerate, right? You get more comfortable with numbers the more you do this kind of crap. So while it's not necessarily all that important, it does at least help with your numeration. All right? So let's do one more, and I do this one because it's one of those problems that I've been trying to work on for literally 7 years. Okay? Two and 3/5%. How do I write that as a decimal? So our gut reaction is to write 2.6, right?
But
Why am I going to mark that wrong?
Because you didn't convert it, because you still have the whole 2, so you have to move the decimal over, so it's actually 260.026.
Okay, good. Remember,
Sorry.
you can convert the fraction, right? You are correct that this is 2.6%. Do not tell me that 2.6% is the same as 2.6. You guys know that that's silly, right? You know it's silly. Okay? So how do you convert the 2.6%? 0.026. Okay? 20% of you on the test in 3 or 4 weeks are just going to write 2.6. And I want it to be only 10% of you. That's been my goal for the last 7 years, is to get 90% of the people to do that percentage correctly. Because this percentage is what almost every savings account has attached to it. That's a enhanced savings account percentage right now. It's 2.25%, it's 2.75%, it's 2.4/5%. That's what the percentage rates are. And they often write them as a decimal. That's what I've seen on the advertising of websites. Okay? Because my wife and I are constantly looking for places to put float money, our nest egg, so to speak, the spare cash that we want to have if our car breaks down, knock on wood again, right? And you want to get as much interest as possible because it's money that technically you're not spending until you run into a problem, right? But again, 2.6%, yes, 0.026 when you convert. Alright? So again, please be careful and do not make the mistake of writing 2.6 on the test. If less than 20% of you do that, I will make cookies for the entire class.
Are they good
Are you a good?
I am a good baker. It's about the only damn thing I can do in the kitchen. So, you know. All right, so now, before we're done, though, how do I convert 0.026 into a fraction?
26 over 1,000.
26 over 1,000, because it's 26 1,000ths. And you will
13 over 50.
13 over 500. All right. Not bad? Okay, so again, like I said, folks, first question. There's going to be 5 rows. Each row is going to have 1 item filled. You have to fill the other 10 empty boxes. 10 empty boxes, 1 point per box, a wonderful 10-point question. Okay? Note that from now on, tests are pretty much always going to be 10 question, quote unquote, 10 questions long. Realize that each question will have 1 to 5 subparts. So I say it's 10 questions, but that's bullshit. But the idea is that the 10 questions are all going to be worth 10 points, and that gives it to be an exact 100-point test. Okay, so and note that all the questions are going to be word problems. Okay, there won't be anything that's not a word problem from now on. Period. All right, that's the way this class is going to go from here to the end.
Okay, so you're talking about making a table like this and we fill in the things. How is that going to be a word problem?
I'm going to have words up in the beginning of it that say, do not round anything and simplify all fractions. That's the
so
word
it's
problem.
not like story problem, word problem.
Oh, yeah, that's the way it's
Are you serious?
going to be.
Oh,
Okay, so you ready for the next word problem that you're going to get?
Yes.
Okay, so here is the sample of the next word problem you will get on the test after that table. We'll start with the simple one, all right? What is, let's go, like I said, keep it simple. How about 15% of, say, 80? And I'm going to show you 2 techniques that you can use to solve these one-sentence percentage problems, okay? There are multiple bazillion different ways of going about it. I tend to show you 2 standard ones that I use. Again, if you have another one that you use, that's great. Continue to use it. Don't sweat it. But I'm just going to show you 2, okay?
It would be 0.15 times 80 equals 12.
Okay, so the first way of potentially doing these problems is what I call the translate technique.
This means equal.
Uh-huh. But first, what's the word before is?
What?
What? What do we write mathematically when we see what?
A letter
X, yes, whatever your favorite letter is. The word is
equals.
equals.
15%.
How do I write 15% correctly in math?
0.15.
0.15, right? You convert your percentage to a decimal because you never actually use the percentage when you're working in math, right? You always use either the fraction or the decimal, which is why, again, I hate the percentage. What does the word of mean? Multiply. And how do I write the number 80?
80.
Yeah, you write the number 80. And then you just have to solve for x, right? And so, in this case, you just 0.15 times 80, what's x? 12. Okay. Now, the other technique, if you have used this technique, I am perfectly okay with it as well. Is over of equals percent over 100. And your job is to fill in what the 3 symbols are. Is, of, and percent. The 100 is always there. Okay? And then you just cross multiply and divide to solve for whatever is x. Okay? This is the traditional nursing technique. It's the proportion technique used to solve most percent type problems. So proportions or percentages are often the same. So in this sentence, when you do these sorts of things, advice from the wise. Okay, if you use is over of equals percent over 100, fill the percent slot first, always. Fill the of spot second, and fill the is spot third. Okay? If this is how you're going to do it, this is just how I ask you to set it up, because this is the safest way to do it. Okay? So, now, here's how you start. You start with the 100 in there already, folks, okay? So the 100 is fixed. It's always there. And that's because of the percent sign, okay? The 100 is there to take care of the percent. So, what number is associated with the percentage? 15, put it in the spot where the percentage is, right? So 15 goes over the 100. What number follows the word of? 80. Therefore, in the of position, note it's in the bottom. That's where the 80 goes. And do the is last. What number is associated with is? What? And so what do we put in for what?
X.
X. And then when you're solving for x and a fraction equals a fraction, it's always cross multiply and divide, right?
80 times
There's your cross for multiplication, and you divide by whatever is diagonal from the x, okay? It's all based on where the x is. It's not always multiply these two numbers, right? If x is here, then you're going to multiply these and divide by that one.
But it would be the same thing if you did it all out like an algebra equation.
Oh,
It's
yes.
like 100x equals blah, blah, blah.
Yep,
Okay.
yep, absolutely, right? And nicely enough, folks, what's 80 times 15? 1,200. And what's 1,200 divided by 100? 12. So either way you do it, you get the same answer. Okay? So whichever one you are most comfortable with, feel free. Okay? Not too bad?
Why can't we just do 80 multiplied by 0.15?
We did, right here. That's the translate. That's fine. You can do that. Either these, what I'm saying is this technique or that technique, whichever one you're happier with. I'm good. Okay? Okay, so let's try the next type of one then. Let's say 20 is, let's make it weird. How about that? How about is 24% of what? So again, either of these two ways of doing it. I'm going to do both potential ways here to start with, so bear with me. I'm always going to do it both ways. I'm going to do the is over of first this time, okay? Please note that for the next test, you get to use a note card. Sorts of things to write on the note card. If you need to remember them and have a little, a little picture to remind you, write it down. This is what I want. I don't want you to memorize this stuff. I want you to write it down and then say, I know how this works, and be able to use it, okay? So, start the problem, though. You've got the 100 in there already. So, what am I going to write in first? The percent. What's my percent? 24. Just remember, where does the percent belong, right? 24. What do I do second?
20 over.
Of, right? Of is what? X. And where does of go? Down below. And then by default, what's the is? The 20.
I feel like doing them both is like a check. Like, you know what I mean? It's the same answer. It
Yeah.
has to be right.
I agree. But again, folks, the reason why I'd like to do this one is just to remind you that this cross multiply and divide technique, folks, it works no matter where x is. Okay? Here is your numbers that are across from each other. That's what gets multiplied. Whatever is diagonal from the x, that's what you divide. Okay? And you can just write that straight out, and that'll get you what x is, right? So x equals 20, oops, I'm blue, times 100 divided by 24.
83.3 repeating.
83.3 repeating. And again, if I don't tell you where to round, that means you shouldn't. So when you see all those threes and you know what it means, give me the repeating decimal symbol, okay?
So you can also 83 and a third.
You could give me 83 and a third too. I would love that. In fact, I'd love that more because I love fractions.
So the answer, do we write that in percent form or we just Google it?
Is that a percentage? No. So do not write it as a percentage, right? Only write it as a percent if the question is asking for what the percentage is. I didn't give you the percent. This has to be a straight number.
Okay.
Okay? So now, how would the translate work, folks?
20 equals
20 equals
0.24
0.24
times x.
times x. And what do you do to solve for x?
Divide.
Divide by the 0.24, right? And nicely enough, what's 20 divided by 0.24?
83.3 repeating.
83.333333. Exactly. So it doesn't matter which technique you use, they are all equally as good. Okay? Either one. Not bad? Okay, now to the hairy one. And this one I will just apologize up front because it's slightly different between the two techniques. So, let's say 27 is what percent of 40?
So it would be 27 over 40 equals x over 100.
27 over 40 equals x over 100.
And then 27 times 100 divided by 40 equals x.
27 times 100 divided by 40 equals x. What's 27 times 100 divided by 40?
67.5.
67.5?
Yeah.
And note, this number is a percent. Please write the percent sign after it.
Because it's asking for it.
Uh-huh.
And the x is in the percent spot.
Uh-huh. Since the x is in the percent spot, you need to write the percent sign. I tend to be nice and not take points off of this when you do it on your homework. Please note that on the test, I will not be so nice. Okay? So if the number is a percent, write a percent. If it's not a percent, do not write a percent, right? So, like on this problem above it, don't write it as 83.3 repeating percent because that's a totally different number, right? So only write the percent when I'm asking for what's the percent, okay? Now, note, the translate technique, folks, is going to be a little bit hairy, okay? So, what do I write?
27 equals x times 40.
Uh-huh. And what do I do to get x by itself?
Divide.
Divide by the 40. What is x equal to?
5%.
0.67.
0.675. Note what happened in the translate technique, folks. You got the decimal. I want the percent. Yep. So note that when you're finding the percent using the translate technique, you have to manually convert from decimal into percent. Okay? Because remember, when we were doing all these other problems, when we had 24%, we didn't write down here 24, right? We wrote 0.24. And so, likewise, when we get our answer back here, it's 0.675. You have to convert it correctly to 67.5%. Okay? So be a little bit careful with the translate technique. And this is often why students actually tend to use the is over of, because then they don't have to worry about it, right? Is over of takes care of the 100, right? Because the 100 is in here, you don't have to do the conversion. It's built in, Okay? Again, you just have to keep that in mind and adjust accordingly. Okay? Alright, not too bad? Okay, so are you ready for some word problems?
What those were the word problems.
Those are not wordy enough, though, right? You guys like them more wordy, right?
With a bunch of useless crap.
What? Would I give you useless crap?
Yes.
Oh,
Yes.
wait, yes, I am that kind of guy. Oh, never mind. Yes, you would get it that way. Okay.
Chickens and dogs and horses and cats.
All right. So let's see. I will try and be nice here in the beginning, though. Okay.
Oh, yes, exactly. 23 of them. What percent of it?
So let's say that Oscar Mayer has total sales of, let's say, $120 million per quarter. It's probably a little low, it's my guess. I guess Oscar Mayer probably is making sales in the billions per year, so it's probably more than that. But this is, perhaps it's a bad quarter for Oscar Mayer. If, let's say, 62% of total sales, not salsa,
Start writing stuff.
from hot dogs, what question am I going to ask?
What was it comes from?
Then, if 62% of total sales come from hot dogs, what are sales in dollars of hot dogs per quarter? Question mark. Okay, so this is this is at least a 2-sentence type problem. It's not just a straight 1-sentence problem where there's not really anything tied to any of the numbers. And so this is where you start running into sort of problems where, okay, how do I handle this? How do I read the correct stuff? Okay? Now, another technique that is used for problems that start to get a little bit wordier. The reason that I like this one is that the formula that I'm going to write is going to be awesome. All right. So the way it works is that the portion is often equal to the base times the rate. So this is a very standard formula that you see in percentages all the time. Portion equals base times rate. And if you abbreviate this formula, guess what it looks like?
P equals times R.
Yeah, it's the PBR formula, folks. And for those of us that grew up on the 30 packs of PBR all summer, that's why I used to work in the summers. I used to umpire Little League. Me and another guy would umpire every night, well, every other night. And once we got paid, that's basically where we went first. PBR, baby. Because a 30 pack was $4.99.
Is it a beer?
Yes.
Yes.
Past Blue Ribbon. Yes.
He's a little older than me.
PBR's disappeared for a while, but they're back. If you want to, they're now.
They don't taste any better.
Yeah, they're
back.
Well, yeah, true. They still.
It'll taste awful.
But now they're $3 a can. It's like, what the? That should be for a 12 pack, right? All right. So portion equals base times rate. Okay. And what I liked again, this is just P is the portion. It's the part. Whatever you want to call it. It's what you're taking a subset of, right? B, which we often call the base, this is also called the total or the whole. And that's the whole with the whole, not the whole that is a whole. If you know what I wholly mean, right? And R is the percent as a decimal. So note that whenever anybody talks about rate, what they're really talking about is the decimal representation of a percent. Okay? So whenever anybody's saying rate, what they're really talking about is a percent, but it's just a percent that's already been converted into its decimal format. Okay? So just realize that that's what that means. All right? And so your job here is to look at this problem and say, okay, what's the portion, what's the base, and what's the rate? Note that we've got an equation with 3 things in it. You're going to be given 2 of them. The third one you're not going to know. Guess what you're going to call it? X. And then what are you going to do? Solve for X. Hence chapter 5. Okay? And this is how I will try and reinforce the algebra on you, whether you like it or not, is because this is kind of the way all of these things are driven. Okay? So, in this particular problem, folks, what's the portion, what's the base, and what's the rate?
Portion 120?
Portion 120. Why is it P the portion 120?
Because that's the part that they're trying to get the percentage of.
It's the part that they're trying to get the percentage of.
It's the total sales.
It's the total sales, and total and part are the same thing.
I got
I'm talking to myself. All I got so far is 62% over 100%.
Okay, good. So, note, folks, when you're doing these problems, if you determine it's a portion equals base times rate problem, take the easy points first, okay? So in this case, you know what the rate is. What is R?
62.
It's 62%, but remember, since it's a rate,
0.62.
0.62. Good. Okay? And honestly, folks, this is the way I would love you guys to write your rates, okay? I will be talking about the word rate forever. For the next 5 to 6 weeks, we will talk about rate. And a rate is always a percent, but it's the decimal representation, okay? Now, the only thing you have to tell me is what's left. And this is where you got to read the sentences carefully, right? Oscar Mayer has total sales of $120 million. If it says it's total, that's the base, okay? So those are the sorts of things, the key words that you're looking for, right? Is the 120 million comes from a total, therefore, that's your base. And by default, folks, then what's the portion? X, okay? Don't forget there has to be an X up in there. And the cool thing about it is, if you put X in the wrong spot, folks, what you're going to go do is get a number that doesn't make any sense. And when that happens, guess what you need to do? Yeah, start over and just flip the portion and the base. And the cool part about it is that that will almost always work. Okay? Alright, so in this case, though, once you have R, P, and B, just use P equals BR. Right? What's P? X. What's B?
120 million.
120 million. And what's R?
0.62.
0.62. So all you got to do is take 120 million and multiply by 0.62. $74,400,000 in hot dogs per quarter. And don't think about what that relates to in the number of pounds of rat tails and pig jowls and pig hooves and all the other things that go into hot dogs that you don't want to know about, right? They put in everything but the squeal. You do realize that there is a regulation on hot dogs for how many parts per million there can be of human flesh inside of a hot dog, right?
There's human flesh in
When you're cutting hot dogs.
Alright.
it. Okay, I'm done eating nachos.
Don't think about it, but it's part of the. If you want to read a book about it, it's not a pleasant book, but you can figure out. There's lots of regulations on hot dogs, and one of them is how much human flesh is allowed inside of it. So
Well, that'll help my weight loss program.
hopefully it's 0, right? But it's still considered a hot dog if there's less than a certain amount. That's the way it works. Okay.
What do they do? Test everyone?
Apparently
Disease
they
before they let them work?
No, they will literally DNA test hot dogs, right? So the RDA will once a quarter grab 200 packages of hot dogs, slice all the genes of all of the different material that's inside of there, and say what makes up these 120 packages of hot dogs.
They're like, oh, there's 1.0000002% of John's left finger.
Right.
Well, but that's it. They'll say that there is, that there in this 1,500 grams of hot dogs, there is 1 gram of human flesh, right? There is 5 grams of pig jowls. There are 10 grams of pig hooves. There are, because they can tell what the DNA.
0.001% chance of AIDS because now there's blood in your hot dog.
Potentially, yeah. I mean, if that could happen, right? They actually splice for that
You know
before
my
they send it
kid's
out.
favorite thing to eat is hot dogs?
Don't think about it then.
Oh my Lord.
All right. So let's see. Let's try another one.
Now I'm gonna go for the normal way. We're only buying beef. Does that? Do we still?
You don't
Let's
wanna
not talk
take
about
ground
pig slime.
beef either.
Okay, so what's the company on the highway just south of here? Hormel. Yeah. Okay. So let's do Hormel. Let's suppose that
chili.
Hormel
All these horror stories.
sells. Let's suppose that Hormel sells. We'll say $15.2 million of chili each quarter. If chili is 65% of total sales, what am I going to ask this time, folks? What are total sales? Not salsa.
You really want some salsa.
I do.
don't you?
Well, Frito-Lay's next.
Per quarter.
Who knows how many fingers are in that salsa?
I think their regulations are a little bit tighter.
Well,
They have enough acid in there too that's broken down for everybody.
Oh, it kind of kills the germs.
There's not enough acid in hot dogs, unfortunately. Preservatives, but those are what keep the parts from not. Yeah,
Right.
enough said. Yeah.
We're preserving body parts in your food.
All right. So, again, one of the keys to seeing that this is a percent equals base times rate problem, or a portion equals or base times rate problem, is note that the 65% is just 65% of something. It's not 65% more or 65% less. It's just 65% of. Okay? So when your percentage is immediately followed by the word of, you are normally dealing with a problem that is PBR, right? Think beer when you see of following percentages. Alright. So, this is a PBR problem. You just need to tell me what P, B, and R are. What are you going to start with?
Great.
Awesome, because that's the easy one, right? What's my rate?
0.65.
0.65. Awesome. Note, folks, on this problem, if you do this is all you write on the test, you have gotten 3 out of 10. 30%.
Do you
Okay.
want us to put the percent and then convert it to decimal, or can we just put
You can
decimal?
just put 0.65. That's perfect. All right, so what's next?
The portion, 15.2 million,
Why is it the portion?
because it's in real money.
Yeah. What did I ask you for? What's the question? What are total sales? If I'm asking you for total sales, what do you not know?
The base.
The base, the total. So therefore, X has to be with the B, and by default, where does the 15.2 million have to be? Portion. Okay, so use a little bit of that logic in this. If you can see that the question is asking for the total, you know that total is base. That's one of the easiest things to notice. Okay? So, again, this is just me trying to give you helpful tricks to solve these sorts of problems. All right. So, now just substitute in for the formula and solve, right? So 15.2 million, 15,200,000, please don't screw that up, equals x times 0.65. What am I going to do to get x by itself? Divide by the 0.65. Okay. And what's 15,200,000 divided by 0.65? Again, this is money. You know where to round. 84,000. What was that?
615.
615.
Cents.
How many cents?
38.
38 cents. Again, money, I should not have to tell you anything about money. You know where to round. Okay? Not bad? Again, so this is just another technique. Folks, this is the exact same as is over of. There's nothing different from this than the other ones, right? In this particular case, portion is always is, base is always of, rate is always percent, right? It's just the same thing. You can actually do PBR when you're doing regular straight one-sentence percentage problems, and just remember that P is the is, and B is the of. It works the same way, all right? All right, so another one. Let's see. Let's suppose I ask you. I like this one. Okay, so I have. Suppose I have 40 marbles left. The older you get, the more they fall out your ears. That's how it works. If, let's say, 17 of those marbles are red, then what percent of my marbles are not red?
So first we need to find the percentage. 17 is of 40,
Why?
because we can use that to find the percentage of everything else.
Exactly. And note that it actually falls straight into a portion equals base times rate type of problem. Just remember that your rate will come back as a decimal and you have to convert it to a percent. Blah, 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 blah. What's the portion and what's the base of my marbles here?
The base be 40,
The base is 40 because that's the total marbles that I have
portion
left.
is 17.
The portion is 17, right?
Won't the portion be 23?
We can get there. Yes. You can do it with 23. We'll get there. Don't worry. Okay. So you can say 17 equals 40x. What are you going to do to get x by itself? Divide by the 40. What's x equal to?
1425, which comes to 42.5%.
Okay, good. Please remember that r is a rate as a decimal. Because it's a decimal, you have to convert it to a percent. what does that 42.5% represent?
The total marbles you have that are red.
Yeah, the percent marbles that I have red, right? So you should say that 42.5% of marbles are red. What did the question ask for?
What percent is the other ones?
What percent are not red? How can I get that percent from up here on this problem, folks?
Subtract 100.
All right. And you guys know what we call the subtraction from 100 of this percent?
57.5.
That's what it is. Technically, the name is called the complement. The complement of a percentage is the other amount that completes or makes the percentage whole. And what is a whole in percentages?
100.
It's a thing on the wall that somebody drilled through, right?
The one that you found your head on.
Yes, exactly. It's 100% exactly. So this is how you can use the complement concept. And this is a very handy complement concept. Complement concept is very handy for dealing with percentage problems, because if you need to get the other piece or the other side, that's how you get it, right? Of marbles are not red. Now, who's talking about 23?
Well, when I was looking at that, I just look at 40 minus 17 equals 23. 23 divided by 40 would be that.
Exactly. Note that this is 17 are red. Did we really want to know what percentage were red? No, we want to know what percentage were not red. We could apply that complement concept a little bit sooner and say, well, if 17 of them are red, how many are not red?
23.
Yeah. 23 are not red, and then we can figure out the not percent in one step instead of having to remember to compute the complement at the end. Again, it's whether you compute the complement at the start or the end. As long as you do it, we're all good. Okay? The nice part about it, right, is that if you do 23 equals 40x, x equals 23 over 40, x equals 0.575, 57.5%. So note, you get the answer the same way, or you can get the same answer either way, right? And as long as you are careful and don't tell me that the answer is 42.5%, we're all good. Okay? Not bad? And again, this is you guys critically reading, right? Seeing that in this question, I was asking for not red and giving you those numbers that are red. Okay? And that's just a matter of you guys reading carefully enough to know that either you need to figure out how many not red marbles there are, or when you figure out the percent, you get the complement at the answer in the end. Okay? Alright, so we're not quite to the end of chapter 6, but we're at a great stopping point, so I don't want to go any further. But note what we need to do still for chapter 6. Is talk about the different forms that we get of percentage increases and decreases, right? So if you get a 25% pay raise, what is your new salary going to be given your old salary, right? How do you go about doing that when you're dealing with percentages, right? You know how to do it, but then there will be different variations on the theme to make sure that you can calculate any value in that percentage increase problem, no matter what I ask you to do. So, for next class, folks, please note, you can start the Chapter 6 homework. Start Chapter 6 homework. But please note that it is not due next week, okay? We'll finish Chapter 6 on Monday, and I'll assign it to be due on Wednesday of next week. So you've got at least, until Wednesday of next week to finish it all. Please note that the homework for Chapter 6 is long. 2 through 92, the evens. It's 46 problems. I strongly encourage working through at least the first page. The first page doesn't deal with any percent increase or decrease, it's just all straight percentages, and that's probably, you know, I think it goes up to like 40 or 50 on the first page. So it gets you the first 20 or so problems out of the way without having to deal with it, all right? So, again though, not officially assigning it, but my advice is give it a whack. Get
Well, I
started.
told they already left class.
Are they all? No, there's still one in the back seat, right?
Yeah, they're gone.
I can't see any of them anymore is my problem. It's gotten so light.
You right in that room?
It's the
Yeah.
Windows or something?
Yeah.
No, they have the blinds over.
Yeah. Anytime there's any sun, the glare is
Yeah,
just,
if you tell them to close them, you'll be able to see without the windows.
yeah.
You can actually see the reflection of us a little better.
Yeah, I know, that's the weird part.
They are awful quiet though.
Yes.
Do I sound like I'm getting it? It just must be my anxiety when I'm trying to do it outside class.
Yeah, I mean, that first part you were like, oh yeah, okay.
Yep. And then I get to a point and I'm going, what the hell did you do now?
I went right before class and finished the test. So that's turned in.
Okay, cool, thanks.
If we have review before our next test, is there any way I could possibly do it in the testing center or whatever, just so I can make sure I get done before class? Like I have to be out of here at 2:25 because I have to pick my kids up at 2:30.
And if you're late, they start charging you.
Yeah, it's $5 every minute after.
Right, yeah.
2:45, which
Right.
is like
Yeah,
So-
it's like, hello. Yeah, no problem.
okay. I don't think it's
Yeah,
like
if you
that
ever
bad.
just need to go, just
Okay, well,
It's cool.
I didn't want to be in the middle of the test and be like, I gotta go, because, I can't afford $45 for 10
yeah, no. I would guess that like I said, that first test is the longest test that I ever
That's
give.
what I was thinking.
Yeah,
'Cause
like I
had
said.
my friend, Alanis Vanderkoy, and she
Yeah.
took your class. She was like, the first test is the hardest, the worst, the longest, and then every other one you'll have, note cards, and it'll be fine. I was like, okay.
And then on the test we just did, I had a question that was going to Jupiter and how much per mile. And so you have two answers that I put on there because you didn't specify whether we were calculating the trip back home.
Oh, you're not going to come back from Jupiter.
So I have two answers. I have a one-way answer and a
Other way, you multiplied it by 2?
yeah.
Okay, cool. That's okay. Thanks, Alicia.
Yep. Thank you.
Oh, crap, I got to stop the recording.